Alrighty guys, so we've had a look at trigonometry and right angled triangles so far, and today what we're going to do is extend that to work in any triangle. Now, the first of these rules that we're going to look at is called the sine rule, and this still works in a right angled triangle, but we just don't use it in a right angled triangle. So let me draw your attention to this triangle up here. So the first thing to identify with any triangle is that the sides and angles are in proportion, or they're in the same ratio if you'd like. So what we notice is, see here, this angle is the biggest angle, it's obtuse, and we notice that opposite that, not coincidentally, happens to be a big side. Now the same is true in a right angled triangle. If we think about it, if this is your basic right angled triangle, the hypotenuse is opposite the right angle, which is the biggest angle. So if we have a large angle, we have a large side opposite it. And in the same way, here at A we have a small angle. So little a that is opposite it is the smallest side in this triangle, and B is the middle angle and the middle length side. So what we have is our sine rule that relates these three sides together. So there's two ways to write it. Our first way is that if I have A being our side, we always use lowercase letters for a side, capital letters for angles. So we have A over sine A is equal to B over sine B, which is equal to C over sine C. They work in pairs, they work in opposites. The capital A, capital B, and capital C are your angles, and your lowercase are the sides. We first need to identify the sides and the angles that they are opposite. We can't just pair them up as we please, they have to be in opposite to one another. So the second way to write this is literally by just flipping each of these ones, taking the reciprocal and writing the angles in the numerator instead of the denominator. Same result, sine C over C. Now the nice thing about this is I'm actually going to strike out these straight away, and you end up with those being our two rules, because we can call side A, B and C whatever we would like, really. So we're only ever going to use two pairs in when we're using the sine rule. So we've got our sine rule here, as I've written, is two sides and two angles. Now that doesn't mean our triangle only has two sides, that makes no sense. But it means that we are trying to find information about two sides and two angles. So in the examples we'll look at in a second, we might be given two sides and an angle and asked to find another angle. That's when we would use the sine rule. However, if I gave you two sides and an angle and said, please go find the third side, we need a different rule for that. That information doesn't fit in here. We couldn't go and put in A, B, and C, but then only have one angle. There's too much going on. We're only ever going to use this version that's in the box here. And if you're trying to find an angle, you're going to use this one. And if you're trying to find a side, you're going to use this one. As I said, they are the same thing, but just how we vary them depends on what we're trying to find. And I think an example will help. So I've got two examples here. Now what you'll notice again, I've got my three pairs of sides in this first triangle, this one, A, B and C being the angles. B is 53 and A is 41, and side A, lowercase a, is 6. Now what we're asked to find in this triangle is B. We're going to try to find B. We could also go find C, and we could go and say that this angle here is 180. I could go say it's 180 minus 53 plus 41. Just employing a little bit of that geometry that we know, and then we could go find side C as well. That would just be a second application of the sine rule, so we're not going to worry about doing that right now. You can have a go at it afterwards if you'd like. And again, if you do that, and if you found all three sides and all three angles, you would notice that they would be in proportion. I'm going to look at this here, and I know, without even performing this sum, that C is going to be the largest angle. So that means little c is going to be the largest side. big A is the smallest angle, so that 6 is the smallest side. I'm expecting something bigger than 6 for B, because 53 is larger than 41. So let's go and write this out. I've got B over sine B, B being 53 degrees, equals 6 over sine 41. Now again, we've got an equation here where this, and this, they're just numbers. Okay, obviously sine 53 and sine 41 are non-exact numbers, so we're not going to estimate them. We're going to type this into our calculator as it is. We're going to have B equals 6 times sine 53, and I got that by simply multiplying both sides of my equation by sine 53, and then that's all being divided by sine 41. We put that in our calculator, we get 7.3039, and that's 7.3 centimetres to 1 decimal place. Now, as I said, I'm expecting an answer bigger than 6. That's what I got. Not much bigger than 6, because it's not like the difference between the size of those two angles is drastic, but it is B slightly larger than A. Performing this the other way, so this time we're trying to find angle A. Now, I have less information this time. I can't go find, without finding angle A first, I couldn't find angle C or side C, unless I wanted to go use a different rule. So in this case, I want to find angle A, and we're a little bit more restricted in this case. So what I'm going to do is say, this time I'm finding an angle, so I start with what I don't know on the top left of my equation. I'm not sure if I mentioned that earlier, but we start with top left here, or here, sine A over 9. We start with top left of our equation with what we don't know. All that means is we're going to have one simple multiplication to get to a point where we can put something in our calculator. If we start bottom left or bottom right, we're going to have to do a little bit more manipulation of these terms, and it just makes life a little bit trickier for us. Not right versus wrong, just making life as easy as possible. So we have our A and 9 matching up, and our 42 degrees and 8 matching up, so it's sine 42 over 8. Again, what if we have sine on top left, it means we need sine top right as well. Okay, so if our angles are on top here, our angles needs to be on top here. Same deal over here, we had angles on the bottom, angles on the bottom. So again, by simply multiplying by this denominator, I end up with sine A equals 9 sine 42 over 8. That can go straight into my calculator. And that gives me a little funny answer of 0.752 and so on. Now, clearly that's not our angle. That's not our angle. It's not 0.75 degrees, but you've also made no error. What we need to actually do is use that shift button in our calculator, find the inverse of sine, and we can press something that looks like this. We go and say our angle is equal to the inverse sine of pressing the answer key on our calculator. What that will do, that uses that exact value. If we round it early, we might make an error. And what we end up with is 49 degrees, and that's to the nearest degree. Okay, so, and again, my sides here, if I look at them, 9 is slightly larger than 8, so I would expect angle A being slightly larger than angle B. I hope that makes sense. Really, this is our first rule, the sine rule for non-right angled triangles. And it really is basically saying the sides in any triangle match up to the angles that they are opposite. Big side is opposite a big angle, small side is opposite a small angle. And the way that we can deal with that is that first formula that we had a look at. So can we make some notes on this? And hopefully that's made a little bit of sense.